Hello everyone, this is Nalini Valavala. Today we are going to discuss about red black trees. So in this topic we are going to discuss about what is the red black tree and what are the properties of a red black tree and how we are going to insert an element into a red black tree. Coming to the basic definition of a red black tree, it is a self-balancing binary search tree in which each and every node is colored either in red or black. Here we are going to see the definition. It is a self-balancing binary search tree in which each and every node is colored either in red or in black. So we have to know first what is a binary search tree. It means BST. So the main property of a BST is when comparing with a root element, the elements present in the left subtree should be smaller when compared to the root element, and the elements that are present in the right subtree or must be greater than when compared with the root element. Here we have taken a 3 elements, that is 15, 10 and 25. Here 15 is our root element. We have inserted 15 into the tree and it became a root. So the next element is 10. So we have to insert this 10 to the left side of 15 because when comparing with the 15, 10 is a smaller element. And again 25. So we have to insert the 25 by comparing with the root element. So when comparing with 15, 25 is larger. So I inserted 25 to the right of 15. This is the main property of a BST. So whenever we are constructing a red black tree, we must follow the properties of a BST as well as the properties of a red black tree. In a red black tree, the color of the node is decided based on the properties of a red black trees. We have told that the color is either red or in black. So this colors is decided based on these properties of the red black trees. So in this red black trees we are having 3 properties. So these properties we are going to term it as an RB1, RB2 and RB3. Coming to the first property, RB1, the root and all the external nodes are colored with the black. It means the root element, which is the topmost element, it should be in a black color, and the elements, all the external nodes, that also should be in a black color. So this RB1 property is also called as a root property or external property. Coming to the next property, RB2, no root to external nodes path have 2 consecutive red colors. It means I should not have a 2 consecutive red color. For example, let us see here. So if this is so here I am representing for our convenience the black node in this shaded part and the red node is in a simple circle. So whenever I represented the circle with the 2 lines, this will be as a black node, and when I represented a simple circle, simple node, this is in my red color. So what is my RB2 property says? No root to external path has 2 consecutive red nodes. It means I should not have any 2 consecutive red nodes. For example, let me take an element 15. So this is my root node and it should be in a black color according to the RB1 property. So I am having another element, that is 10, and I should also follow the properties of a BST. So when inserted 10, it should be the left of 15. And this is in a red color. So I am having another element 5. Let us assume. So 5. Here I am having 2 consecutive red colors. This is a red color and this is a red color. RB2 property says that we should not have 2 consecutive red colors. Next, coming to the RB3 property. All root to external paths have the same number of black nodes. It means from root node to all the external paths, we should have an equal number of black nodes. Let me clear these properties with an example. So I have taken an example with these elements. So I am applying these 3 properties in this tree and I am checking whether it is a red black tree or not. So this is a tree. Here let me first see whether it is a BST or not. So 65, it is a root node, and I have inserted 50 to the left. When comparing with 65, it is a lesser element. So 40 to the left of 50 and 60 to the right of 50, as well as 80 is greater than 65, it is in right side, and 70, it is lesser than 80, it is in left side. 5 is less than 40, it is in left side, and 62 is greater than 60, it is in right side. It is my BST, no doubt. Now we have to see whether it follows the properties of a red black tree or not. So what is my first property? RB1, that is, see here, the root on all the external nodes are colored with black. It means the root node and all the external path nodes, it should be colored in black. So I have already mentioned earlier that I am representing the black nodes with a double lines and the red nodes within a simple circle. It means this is my black nodes. So all my root node and the external node should be in a black color. It is satisfying that property. So RB1 is satisfied. Now coming to RB2. It should not have a 2 consecutive red colors. So where is the red color here? Here 50 is in red color. Is it having any 2 consecutive red colors? No. So 70 here. Any consecutive red nodes? No. So it is not violating the property of a red RB2 property. Next coming to RB3. What is RB3 property? All root to external node paths have same number of black nodes. It means from root to external path, whatever the path it is, it should have a equal number of black nodes. So here 65. This is my starting node. I am checking this path. So this is one path, and this is one path, and this is one path. So from here 65 to 5, it is having one black node. So from 65 to in this path, it is having one black node. And from 65, 50, 60, and in this path, it is having one black node. So from this 65 to 80 to 70, in this path, I am having one black node. Is it having an equal number of black nodes all among the tree? Yes. So absolutely it is a red black tree, because it is following both the properties of a BST as well as the properties of a red black tree. These are the properties of a red black tree. Now I want to see how I am going to insert an elements to a red black tree. It means insertion. So first insert an element in a red black tree using BST property, as we have discussed it earlier. By using only BST property, we are inserting the elements, and every newly inserted element should be in red color. So here it is mentioned as red color. Every newly element should be in red color. If tree is empty, then newly inserted elements become root. Let me take a few elements as an example, that is 5, 10, 3, whatever it may be. So if at all the tree is already constructed like this 5, 10, 5, 10 and 3. So if I am inserting this element 3 now, so this is a newly inserted element and it should be in red color. That is the thing of this first point. Is coming to the second point. If tree is empty, then newly inserted element becomes the root. Here, if at all I have not constructed any tree, this is the starting element. So 5, this becomes the root. As well as it is a newly inserted element, but it is a root node. So this should be in a black color. If the tree is not empty and the newly inserted element is at either left or right of the root, and it should be in red color. So simply 5, 10, 3, we have already an example. So 10, according to the BST property, I have to insert 10 to the right of 5. So it is a newly inserted element and it should be in red color. So 3 3 is also a newly inserted element and it will be left of 5. These are the main things. So next, here if at all I have to insert another element, that is 2. So where I will insert this 2? To the left of 3. Is it so? But is it violate? I am having the properties RB properties, that is RB1, RB2 and RB3. So when compared with these properties, is it violating any property? Yes, it is violating RB2 property. What do you mean by RB2 property? No two consecutive red nodes should be present. It means from root to external path, we should not have any two consecutive red nodes. So in this case, it is violating the property of RB2. So here the tree is imbalanced. For balancing, we are having and the things, that is, example, see here, I represented the nodes with U, PU, GU and UN. So let me clarify what these things are. U is the newly inserted element. I am considering U as a newly inserted element, and PU is nothing but the parent of U, and GU is nothing but it is a grandparent of U, and here UN is the uncle node. If at all the tree is imbalanced in any situation, we are going to based on the color of this uncle node. See, this is, for example, for U it is a newly inserted node. Let us assume it is U and it is a parent of U and it is a grandparent of U people, and it is a uncle node for this U. Is it clear? Then I am going to balance this tree based on the uncle node. So based on the color of this uncle node, here the uncle node color is in red. It means it falls under a condition of X, Y, R. If at all the uncle node color is in black, it comes under the category of X, Y, B. So we have to know what is this XYR and XYB. So XYR. If the uncle node is in red color, there are 4 cases. That is LLR, RRR, LRR and RLR. So if we got a condition of XYR, and these are handled by recoloring techniques. So how we are going to recolor? So in this we are going to recolor the GU to red and PUUN to black. GU means grandparent of U and PU is parent of U and UN is uncle node of U. So these are the coloring we are going to take place. These are the coloring changes. So coming to XYB, it means the uncle node color is in black color. Then we are going to have a 4 cases, that is LLB. LLB means left rotation, right, left and right left. These are the rotations we have seen earlier in a AVL trees. You are clear about these rotations, LLB and RRB. In this case, we are going to apply both the rotation and recoloring techniques. And this we are going to apply the rotation, that is according to these rotations LL based on LL or RR if it is LR. So here LL, RR, these are the single rotations and these are the double rotations. If it is a LR rotation, we are going to apply RR and then LL rotation and then followed by a recoloring technique. So in this case, in this LL and RR, we are going to change PU to black and GU to red, and whereas in this LR or RL, these are the double rotations. In this, after rotating, we are going to change the U to black and GU to red. Coming to LLR, the new node U is inserted at the left of GU. It means U is inserted to the left of GU. So it is an LLR. It means the uncle node is in red color. Here the tree is imbalanced because it is having two consecutive red colors. That's why it fall under the case of XYR, and that too it is an LL rotation, left rotation. So how you are going to handle this imbalance? As it is an XYR based condition, so we are going to apply only recoloring techniques. If at all it is a XYB, we are going to handle it by using both rotation and as well as recoloring. So here we have to recolor the nodes. So here we are changing that GU to a red color and PU and UN to black. So that is the condition. So we have to change the nodes of PU to black, PU to black and UN to black and GU to red. So here G from black to red. So in some situations, if at all this GU is a root node, so here I am not considering the GU as a root node. I have just taken some part of a tree. If at all GU is a root node, that in that case I should not change the GU from black to red. It should remain as a black if at all it is a root node. So here I am considering some part of the tree. I am not considering this GU as a root node. So I changed the GU to red. Next, coming to LRR. So in this case I have inserted the new node U at the left of right of GU. So from the left and right of GU, this is left and right, this is LRR because UN is in a red color, this is in black color because okay. So in this condition it falls under condition of LRR, so I have to apply recoloring technique. So how I will recolor? So I have to change the GU color to red and PU and UN to black. It means GU to red, PU to black and UN to black. So here, so whatever the case, so we have seen LLR, it is similar as all the conditions are similar, LL, RR, LR, RL. So in all these conditions, if uncle node is in red color, we have to change GU to red and PU and UN to black. And the next case is XYB. It means the uncle node is in black color. So in this again we are having four cases, that is LL, RR, LR, RL. And coming to LLB, let me consider a tree GU, PU, U and N. So here it is a LL rotation and the uncle node is in black color. So in this condition we have to handle this imbalance by both the rotation as well as a recoloring technique. So it is a LL rotation, we are going to apply LL and then we are going to recolor. So in this recoloring will be this, I have to change this PU to black and GU to red. First of all I have to apply a LL rotation. How we will apply LL rotation? This is the imbalance occurred here and this we will imbalance this part of the tree and we will make this PU to the root. Then how it will be changed means, here the PU will be a root element, U, GU and UN. So now I have to change the colors of PU to black and GU to red. So I have done my rotation. Now I have to do my second step, that is recoloring. In this case I have to change the PU to black. This is PU and I am changing this PU to black and I have to change this GU. Here it is in black color, I have to change this is in red color, here it is in red color. So the remaining color as this, we should not change the remaining colors. Here U is in red color, I remind U as in red and UN. So here UN is black, I remain UN as a black. So is it violating this two? Here it is not violating RB2, it is not having two consecutive red nodes. This is about LLB. So next condition is RRB. It means right rotation, and B means here the uncle node color is in black. So here the imbalance is occurred because of the two consecutive red nodes. It is violating RB2 property. So in this case we have to apply two things, that is, first we have to rotate the tree and then I have to recolor the tree. It is an RR rotation, it is having in right side and it is a RR rotation. In this RR rotation we will transform this tree and this likewise, that it means PU will be my root node. PU, PU, GU, UN and U. So I have done the rotation. Next I have to recolor. So how I will recolor this? I will change the colors of PU to black and GU to red. So here I am applying the recoloring technique. So I changed PU to black color and GU to red and remaining colors as it is. So this is the transformation. I have applied both the rotation as well as the recoloring techniques. Here I am not getting a two consecutive red nodes. So next one is LRB and RLB. So in this LRB and RLB, so we are going to change the U node to black and GU to red. Let us see now. Now the next one is LRB. So here GU, so I am inserting the new node U. So I am inserting to the left and right of GU. So here again I got an RB2 violation. It means I am having a two red nodes. So it is a left right rotation. So left right, LR and RL or both or the double rotations. In this case we have to apply two rotations. That is, first we are going to apply RR rotation and then LL rotation and then we are going to recolor it. First we have to apply RR rotation. If I apply RR rotation, how this tree will be transformed means, here it will change these two positions U and PU and it will be like this: GU, U, PU, UN. So the color remains as it is. This is GU color black, UN color black. So now I completed one rotation, that is RR. Now again I have to apply LL rotation. So if I apply LL rotation, again I will change this position of these nodes. It means the center node, that is U, will be my root node. U, PU, GU and UN. So now I have done both the rotations, that is RR and LL. Now I have to recolor this tree. So now I am drawing as it is the colors GU black and UN black. These both are in red colors. So now I have to apply recoloring. So how I have to apply recoloring? Which nodes I have to change? So in this LRB and RLB, I have to change U to black and GU to red. So where is U here? Here U. I have to change this U to black and GU to red. I have to change this GU to red. Again remaining colors are as it is. That's it. This is about LRB. So similarly when we going for an RLB rotation, it means how this RLB is. Let us see here. RLB. So coming to RLB, right left rotation, it means here we are having two consecutive red nodes and the uncle node is in black color. So if it is a RL rotation, it is a double rotation. So we have to apply that is two rotations, that is LL and RR. After applying these rotation, then only I can recolor my tree. So here it is right and left of the GU. So U is inserted to the right and left of GU. It is a RL rotation. So I have to apply LL rotation first. If at all I apply LL rotation, U will be shifted to this place and PU will be the right of U. Likewise, GU, UN, U and PU. This is my left rotation. So I shifted the position to U here and PU to the right of U. So colors are as it is, GU to black and UN to black. Again I have to apply RR rotation. RR rotation. So if I apply RR rotation here, U will be my root node. So simply the tree will be transformed like this. Simply like this. It means U, GU, PU and UN. I will remind these colors as it is, GU is in black and U is in black. So I have completed both the rotations. Now I have to recolor. So recolor means I have to change the colors of U to black and GU to red. So here I have to change U to black. So I changed U to black and then GU to red. I have to change from GU, here it is GU is in black. From black to I have to change it is to red. And the remaining colors are as it is. Is it clear? That means we have cleared all these rotations, both in XYR as well as in XYB. Now let us have a quick review about these red-black trees. So here red-black tree, it is a self-balancing binary search tree. It means it is going to follow both the binary search tree properties as well as the arbitrary properties. So binary search tree property, as we all know about our BST property, that is left subtree should be smaller when compared to the root element and right subtree should be greater when compared with the root element. So and along with this we are going to follow the red-black tree properties, that is all the root and external nodes should be in black color. We should not get two consecutive red nodes, and from root to the external path we should have a equal number of black nodes. These are the properties. And coming to the insertions, so first of all we have inserted any element, it should be in red color. If at all this tree is empty, then only the element that I have inserted will be in a black color, otherwise all will be in a red color. So then if at all we are getting any imbalances, it means how we will get imbalances here. I will mostly here in this case in insertions only RB2 property will be violated. It means we are going to get a two consecutive red nodes. It means these violations, it means these imbalances are handled by both the XYB conditions and XYR conditions. It means based on the uncle node. So whenever we are inserting, we are going to follow only the uncle node color. It means based on this uncle node color only we are going to change this tree to a balancing tree. So this two imbalances XYR, it means uncle node is in red color. At that time I am going to change GU to a red and PU comma UN to black. So if uncle node is in black color, if that cases are LL and RR, first I am going to rotate. If uncle node is in black color, I am going to rotate and recolor. If it is in red color, I am going only recoloring the nodes. So here I am changing PU to black and GU to red, whereas in LR, RL, these are the double rotations. After rotation, I am changing U to black and GU to red. These are all the conditions when I am going to insert a node into a red-black tree. So this is about red black trees. I think this will be very helpful for your quick revision. So thank you.